Chemical kinetics. Chemical kinetics, the branch of chemistry which deal about speed of a chemistry reaction, factor, reflecting rate of reaction, and mechanism of chemical reaction, mechanism of chemical reaction. The the branch of 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 a chemistry which deal about the branch of a chemistry which deal about speed of a chemical reaction chemical reaction factor, affecting rate of a reaction, and mechanism of a chemical reaction mechanism chemical reaction. The branch of a chemistry which deals about the branch of a chemistry which deals about speed of a chemical reaction, speed of a chemical reaction, factor affecting mechanism 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 of a chemical reaction effect. The branch of a chemistry which deals about the branch of a chemistry which deals about the branch of a chemistry deals about the branch of a chemistry deals about the, the branch of a chemistry deals about the branch branch of chemistry which which deals about speed speed of a rate speed of a chemical reaction. Wait, what is the branch of a chemistry which deals about speed of a chemical reaction, factor affecting the factor affecting factor affecting rate 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 of a reaction, factor affecting rate of reaction, factors affecting rate of reaction factor rate of reaction. Mm, factor factors affecting rate of a reaction of a reaction. And mechanism of a chemical reaction, and mechanism and mechanism 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 of chemical reaction, Chemical reaction. The branch of a chemistry, the branch of chemistry, the branch of a chemistry, the branch of a chemistry which deals about speed of a chemistry reaction, chemical reaction. The branch of a chemistry, the branch of a chemistry which deals about the branch of chemistry which deals about speed of a chemical reaction, factor affecting rate of a reaction and mechanism 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 of a chemical reaction is called chemical kinetics. What is chemical kinetics? The branch of a chemistry which deals about which speed of a chemical reaction, chemical factor affecting rate of a reaction and mechanism of chemical reaction. What is chemical kinetics. The branch of a chemistry, which deals about speed. The branch of a chemistry which deals about speed of a chemical reaction, factor affecting rate of a reaction and mechanism of a chemical reaction. The branch of a chemistry which deals about speed of a chemical reaction, factor affecting rate of a reaction and mechanism of a chemical reaction is called chemical kinetics. The branch of a chemistry which deals about the branch of a chemistry which deals about speed of a chemical reaction. The branch of a chemistry the branch of a chemistry which deal about speed of a chemical reaction, factor affecting rate of a reaction and mechanism of a chemical reaction. Mm, Rate of a reaction. Let us consider general chemical reaction. Rate of reaction. Let us consider general chemical reaction. Or reconsider, reconsider, reconsider product. Mm, Rate of reaction. Let us consider general chemical reaction. Mm, Product, reactant, reactant product or reactant product. During a chemical reaction, the represent re- during a chemical reaction, the re- reactant during a chemical reaction, the reactant and transform into product. As a result, molar configuration of a reactant are decreases and the molar configuration of a product R is increases with passage of time. Reactant are decreasing and product are increasing with passage. The rate of a decreasing, the rate of a decreasing, the rate of a decreasing, the rate of a decreasing in the rate of a decreasing in molar configuration of a reactant and the rate of increasing in the reactant decreasing in a molar configuration of a reactant. the rate of a decreasing in a molar configuration of a reactant, and the rate of increasing in molar configuration of product is reactant decreasing, product increasing. Rate of a reaction, the rate of a decreasing in a molar configuration, the rate of a decreasing in a molar configuration, the rate of a configuration, the rate of a decreasing in a molar configuration, the composition of a product, increase product, decrease reactant. Rate of a reaction is equal to minus d into r minus d into r on dt plus dp plus dp upon dt reactant product minus d into r upon dt plus d into p upon dt. Unit of a rate of reaction, unit of a rate of reaction, unit of a rate of reaction, unit of a rate of reaction. Um, Unit of a rate of reaction, unit of a rate of reaction, unit of a rate of reaction, unit of a rate of reaction. Let us consider general chemical reaction. Let us chemical. Let us consider general chemical reaction. Reactant, product. Reactant of a reaction minus d into r upon dt. Rate of reaction plus d into p upon dt. Molar upon second, liter per second. What is rate reaction, and write its unit. Mm, Reactant are decreasing, the multiplication of a decreasing reactant, and the rate of a molar configuration of a increasing of a product unit molar per second. What is real name? The branch of deals about speed of a speed of a chemical factor. Average rate of a reaction, average rate of a reaction, and instantaneous in instantaneous rate of a reaction, average rate of a reaction, and instantaneous of a reaction, average rate of a reaction, and reaction, and instantaneous rate of a reaction, average rate of a reaction. It is denoted by RAB, average rate of a reaction. RAB, small RAB. Let us consider a general chemical reaction. Let us consider a general chemical reaction. A plus B equal to C plus D, C plus D. Later, where A and B are reactant, A and B are reactant, C and B are product. A B are reactant, and B C are product. Mm, at any time t1, D equal to D into I, D into I, D into I. At any time T1, D equal to D into T, D into T, D into T. At any time T2, D equal to D equal to D into F, D equal to D into F, D equal to D into F. Any time T1, D equal to D into I, D into I. D2 equal to D equal to D DF, 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 DF. Change in molar configuration of D into DF, PF, and minus DI as delta, 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 delta into TD. Time interval T2 minus T1, T2 minus T1, T2 minus T1, T2 minus T1. RAB average rate of reaction is equal to DF minus DI, D2 minus D1. Con- RAB is equal to delta into D, AT delta T. The above rate of reaction, the above rate of reaction, the above rate of reaction, the above rate of a reaction is called the average rate of a reaction if the time interval delta t is large. The above rate of the above rate of reaction is called average rate of a reaction if the time interval delta t is large. Instantaneous rate of reaction, the rate of instantaneous the rate of a chemical at a perpendicular time. The rate of a chemical reaction in a perpendicular time is called instantaneous rate of a reaction. It is denoted by RINS equal to plus D into C upon dt. Write the rate of a chemical reaction A plus B is equal to C plus D. Rate minus D into A upon dt is equal to minus D into B upon dt is equal to D plus D minus negative positive negative. Mm, in the reaction R in the reaction R equal P, the concentration of a reactant R change from 0.03 meter to 0.002 meter in 25 minutes. Calculate the average rate of a reaction in both unit meter per second and second per second. Ri is equal to 0. T1 T2 Ri T1 T2 Ri contribution delta T is equal to 25. Delta is equal to 25 into 60. Rate of rate laws rate laws rate laws rate laws the expression which deals the expression which rate of a chemical reaction to the molar consonant of each mm, so having some numerical script which may or may be not equal to coefficient. Let us consider a general chemical reaction. A A plus BB plus CC product. Where A, B and C are reactant A, B and C are coefficient rate proportional proportional X upon B power Y into C power Z. Rate equal to K Ax into By into Cz, where K proportionally proportionally constant. Personally, rate of law, the expression which reacts to the rate of a chemical reaction to the molar condition which proportionally constant rate of constant or velocity constant or a specific rate of constant. Let us consider a general chemical reaction A plus BB plus CC product AB and C are reactant A or B, A or B, A or B, A or B, A or B and C or stoichiometry coefficient. The rate of a chemical, the rate of a chemical reaction, when the molar con, concentration of each reactant is equal to the 1 meter each called a reactant constant or velocity constant or a specified rate of constant. What is rate constant and specified rate constant or velocity constant? The rate of a chemical reaction when the molar constant the chemical molar configuration of each reactant. The rate of a chemical reaction when the molar configuration of each reactant is equal to 1 meter 1 meter. The rate of a chemical reaction when the equal molar configuration of each reactant is equal to the 1 minute each per reactant constant or velocity constant and a specifier rate constant. Mm, the rate of a chemical reaction when the rate of a chemical the rate of a chemical reaction when the molar configuration of each reactant is equal to the 1 meter each called rate of a constant or velocity specifier. What is rate of a constant and a specifier rate constant or velocity constant? Order of a reaction, the algebraic sum of a power of the configuration term in the rate the rate law. The algebraic sum the algebraic sum of the power of the configuration term in the rate law expression is called order term in the rate law. The order of a reaction can be determined by chemical reaction, ex- but it cannot be determined by the balanced chemical reaction. The order of a reaction can be determined by chemical reaction, but it cannot determined by the balanced chemical reaction. The order of a reaction may be 0, 1, 2, 3, and even a fraction. The order of a reaction may be 0, 1, 2, 3, and even a fraction. Let us consider general chemistry reaction A plus BB plus CC P rate proportional AX into BY into CZ at K constant K AX into BY into CZ, where K is a rate constant, velocity constant. K is equal to rate constant and velocity constant. Order of a reaction X plus Y plus Z. Mm, Order of a reaction X plus Y plus Z. The branch of chemistry which deals about the speed of a chemical reaction, factor, affecting rate of a reaction, and mechanism of a chemical reaction is called chemical kinetics. The rate of a reaction. Let us consider general chemistry reaction. Reactant, product. During a chemical reaction, the reactant and transform into form product. As a result, molar configuration of a reactant and decreasing, and the molar configuration of a product are increasing with passage of the time. The rate of a decreasing in molar configuration of a rate, and the rate of a increasing in molar configuration of a product is called rate of reaction. Rate of reaction minus d into r upon dt, plus d into p d upon d dt. Unit of a rate of reaction. Let us consider general chemical reaction. um, R equal R P R P rate of a reaction, rate of a reaction, rate of reaction, rate of reaction, rate of reaction, rate of reaction is equal to minus d R upon dt. dt. Rate of a reaction plus d R upon dt. Molar 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 per second, molar per liter, molar per liter, minute per second. What is rate of a reaction and what is unit? Average rate of a reaction and instantaneous rate of a reaction. Average rate of a reaction, it is denoted by RAB. Average rate of a reaction. Let us consider general chemical reaction A plus B plus C plus D plus C A plus B plus C plus D. A and B are reactant. A and B are reactant. C and B are product. at any time t1 80 80 and time t1 d equal d I d I 80 and time d2 molar configuration of d2 equal to d1 df, changing in molar configuration of ddf minus di mm, plus delta d time interval equal to d2 minus d1 d2 minus d1 t2 minus t1 delta t d2 minus t1 delta t the above rate of reaction is called the above rate of reaction is called the average the above rate of reaction is called the average rate of reaction if the time interval delta is large. The rate of reaction is called the average rate of reaction if the time interval the above rate of reaction is called average rate of reaction if the time interval delta t is large instantaneous rate of a reaction the rate of a chemical reaction at a perpendicular time the rate of a chemical reaction in a perpendicular in a at a perpendicular time the rate of a reaction 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 the rate of a chemical reaction at a perpendicular is called instantaneous perpendicular time it is denoted RINS. Write the rate of a chemical reaction A plus B equal to C plus D. Negative positive rate law the expression which react the rate of a chemical reaction to the molar configuration of some numerical some numerical superscript some numerical superscript which may or may be not equal to the let us consider general chemical reaction A plus BB plus CC product where A, B and C are reactant. A, B and C are coefficient reactant constant or velocity constant. The rate of a chemical the rate of a chemical when molar configuration of each reactant is equal to 1 called reactant velocity. Each reactant order function the algebraic sum of power the algebraic sum of the power of the configuration term in the reactant law expression the order of a reaction can be determined by chemical reaction but it cannot determined by balanced chemical reaction. Mm, the order of a reaction may be 0, 1, 2, 3, and even a fraction. Let us consider general chemical. The order of a reaction may be 1, 2, 3, and even a friction. Let us consider a general chemical reaction. Order of a reaction X plus Y plus Z. x plus y plus z, x plus y plus z, x plus y plus z. Talk the cubic sum of the power of the configuration term in the rate on the expression is called order dxl. What is inheritance? What is inheritance? The capability of a class inherits the properties of a one class to another class is called inheritance. Inheritance. Mm, Properties are inheritance by another class. Inheritance the properties to forming two classes. The capability of a class to inherit. What is inheritance? What is inherit? The capability of a inherit the properties of a class in one class to another class. One class to another class. Base class properties are inherited by another class by another class by another class by another class by another class. Inherit the properties of another class. Inherit the properties of a inherit the properties of another class. Inherit the properties of another class. Inherit mm, inherit inherit of the properties of another 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 class. Properties properties of inherit of one class another class inherit properties of inherit are properties are properties are inherit by another class. Properties are inherit by another class. Those class which are inherit the properties of another class. Property of another class. Diagram of a both class, base class B, trap class C. Properties of inherit of another class. Properties are inherit of another class. Inherit properties of another class. Inherit the properties of another class. Properties are another class. Advantage, need of inheritance, capability to express the inheritance relationship. Capability to express the inheritance rela- relationship. Reduce time saving, listed cost. Easy to expand types of inheritance: single, multiple, multi-level, hierarchical, hybrid. Single, when a subclass inherit from a single base class. Subclass inherit from a single base class. Subclass inherent base class. Multiple when subclass inherit from a multiple base. मतलब देगा एक क्लास लेगा multi-class inheritance from a class, and that itself. Hierarchical when a subclass inherit of a multiple class from a single base class. When a subclass, some class, subclass. When a subclass inherits in multiple class. Base class, subclass. Hybrid, the combination. Hybrid inheritance. The combination of a two or more than two inheritance, each called hybrid inheritance. सिंगल इनहेरिटेंस एक क्लास देगा एक क्लास लेगा, मल्टीपल इनहेरिटेंस बहुत सारा देगा एक क्लास लेगा, मल्टीपल लेवल खुद देगा खुद लेगा, हेरिडिकल एक लेगा बाकी और बहुत सारा लेगा। हाइब्रिड किसी भी इनहेरिटेंस में किसी भी दो को मिला के कोई भी दो इनहेरिटेंस को मिला देने से वो हाइब्रिड देने वाले को बेस क्लास कहते हैं, लेने वाले को सब क्लास कहते हैं। एरो का माथा तरफ दिया जाता है, एरो का पूछ तरफ लिया जाता है। Function overriding. What is function overriding? What is function overriding? The function having same name and same argument each called function overriding. Same name and same name and same argument, 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 each called function overriding. Operator overloading, operator loading. Operator overloading can be used to add two complex number, can be used to add odd, can be used to add two number. It is reduce the operator. The keywords of operator: overriding, overloading. Is operator. Visibility mode. The role of visibility mode in inheritance are private, public. Mm, Visibility mode: public, private, private, protect. Private, public, protect. Mm, Protect public cannot be directly accessed to drive. Data file handling help us to store the information in a storage device. Per- it is store the information. It is help to import the information. Data file hiding. Stream in stream.h. It is a header file. It is a standard for file stream. If stream input data input file stream, IF input is used to read the information. Read the information. It is used to information of output write and create file stream input output and read write and create information. Stream the flow of data each call is stream the flow of data the flow of data each call also known as stream. The flow of data 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 is also known as stream. The flow of data is called also known as stream. It is used to sequence by bytes each called stream. In other word, a sequence of byte is called stream. Get care get care. The both input and output function in C++ for single character. The both input or output, both input or output, both input and output, both input or output, both input and output, both input and output, both input and output. both input and output in C++ programming. Programming for a single character. uh, stream read clear pointer. A pointer is some type of variable that all the memory address. Okay. Huh. Pointer is a special type of variable. Pointer. Pointer. What is pointer? What is pointer? What is pointer? A pointer is a special type of variable. What is pointer? It is a special type of a variable. What is pointer? It is a special type of a variable. What is pointer? It is a special type of a variable. What is pointer? A special type of a variable. What is pointer is a special type of variable. So we have all the another variable data types. Operator of pointer. Operator of pointer. There are two types of operator is used. Pointer. Those operator used to store the value variable. Value of variable. It is used to store the value of variable. Those operators used to store the memory address location of another variable. Another variable of it is stored to memory address location of another variable. Int x normal simple variable x normal simple variable int pointer variable please use x store the memory address. C++ memory map after compile the program C plus will create for region for a specific tasks. After can compile the program will create for a region for a specific tasks. Specific stick 3 global program code 1 global variable to have for stick 3 static member all collection all the compiler time locate in C++ statics compile time each called a statics memory dynamic runtime static compile statics runtime runtime dynamic memory normal simple pointer variable uh, whereas a variable that can be stored the value in C++ programming each called normal special value as a variable that can be stored the memory at location of another variable each called pointer variable. Take the branch of physics we deal about a study light and phenomena react to light. Study light and phenomenal the branch of a physics which deals about the branch of a physics which deals about a study light and phenomenal react to light each called optic the branch of optics ray optics the branch of optics is which light is represent is form of ray which light is represent in form of ray each called ray optics. Light, the form of energy which stimulates sense of sight to our eyes. The light always travel in a straight path in a homogeneous medium. The light was travel in a straight path in a homogeneous medium. The speed of a light in different media in the different media the speed of a light in in a different media are different the light travel with large speed in vacuum equal to into 10 the power 8 meter per second it is measured by c is equal to 3 into 10 the power 8 meter second reflective index the relation of speed of light in vacuum the relation of speed of time in vacuum to the speed of time light in the same medium is called reflective index of the medium. It is denoted by omega is equal to c upon v. Reflective index of any medium is a unitless and dimensionless. Reflective index of any medium is greater or equal to 1 omega less than 1 omega less than 1 reflective index of a different media are different calculate speed of light in a medium having reflective index 3 by 2 c is equal to 3 into 10 the power 8 meter per second. Omega is equal to 3 by 2 omega is equal to 3 by 2 c is equal to 3 into 10 the power 8 meter per second. What is b omega is equal to c upon v 3 by 2, it will 3 into 10 the power 8. 3 cancel to 2 into 10 the power 8 meter per second. Reflective, reflective, relative index. One medium or represent respect. One medium with respect to reflective index of another medium is called relative reflective index. Relative reflective index of a first medium reflective index of first medium. Right. With respect to with respect to RI of a second medium, RI of a first medium, RI of a second medium. The medium having the medium in large reflective index comparison with another medium is called um, denser medium. Mm, large reflective index comparing with another medium. Large reflective index comparing with another medium. The medium having a smaller reflective index comparison with another medium. Ra- Rarer medium reflection of a light, the phenomenon of a bouncing back of a ray of light in a same medium after a string of a surface. It's called reflection of a light. Angle of incident, angle R is equal to angle of reflection. Kerosene angle, incident, reflective, normal, reflecting surface. Scene angle, the angle made by incident light are refused with a reflecting surface are called scene angle. They are denoted by alpha and beta. Alpha is equal to beta law of reflection of light. Incident light, reflective light, and normal lie in same plane. The angle of incident must be equal to the angle of reflection. Angle I is equal angle R. Mirror, the part of a transparent glass whose one side is polished is called a mirror. The transparent of a glass, the part of a transparent glass whose one side is polished is called a mirror. The part of a transparent glass is whose one side polished one side polished is called mirror. Types of mirror: plane mirror, spherical mirror. Plane, the part of a transparent glass whose one side is polished is called plane mirror. The part of a transparent glass whose one side polished is called a plane mirror. A spherical mirror, the part of a spherical transparent glass whose one side is polished is called a spherical mirror. Spherical transparent whose one side of polish is called a spherical mirror. Have it has two types. It have two types. Concave mirror, concave convex mirror. Mm, convex inside, polished in inside, polished in inside. Concave outside, polished. Some basic term related to a spherical mirror. pole. The midpoint of a spherical mirror is called pole. The midpoint of a spherical mirror. The midpoint of a spherical mirror is called pole. Center of a curvature. C. It is denoted by C. The center of a spherical transparent glass of a which a spherical mirror forms a part is called center of a curvature. Spherical transparent glass of which the the center of a spherical transparent glass mirror form a part each called central of a curvature. Principal axis the line joining the line principal axis the line joining pole and create center of curvature each called pole axis. The line joining pole and central curvature each called principal axis. Principal axis radius of curvature are the direction between the pole and the center of a curvature each called the radius of a curvature. The direction between the pole and pole 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 and center of curvature focus. A pointer of the principal axis. The pointer of a principal axis through which a ray of light incident parallel to principal axis passing or parallel well passes or appears to passes after reflection is called the focal length. The distance between the pole and focus is called focus length. The the distance between the pole and focus is called focal length. The distance between the pole and focus is called focus length. Light pole is the center of curvature. Principal axis light normal radius of a curvature. Law of reflection of light. Incident light, reflective light, and normal are lie in the same. Incident light, reflective light, and normal are lie in same plan. The angle of incidence must be equal to angle or reflection. Angle I equal angle I equal angle R. Mm, Incident light, reflective light, and normal light lay in same path. Reflective light, reflective light, incident light are lie in same plan. The angle of incident must be equal to the angle of reflection. The angle of incident must be equal to angle of reflection. The angle of incident must be equal to angle of reflection. Mirror. The part of transparent. The part of a transparent glass whose one side is polished. The part of a transparent glass the part of transparent glass whose one side is polished. The part of transparent glass the part of a as in the part of a transparent glass the part of a transparent glass whose one side is polished is called mirror. Types of mirror. There are two types of mirror: plane mirror, plane mirror, plane mirror, plane mirror. The part of a mirror transparent glass whose side are polished. One side is polished. Spherical. The part of a spherical transparent glass. Part of a spherical transparent glass. Whose one side is polished. Whose one side are polished. Mm, concave, convex. Some basic terms related to a spherical mirror. A spherical mirror pole. The midpoint of a spherical mirror each called poles. The midpoint of a concave. The midpoint of a spherical mirror is called pole. Center of curvature. The center of a spherical transparent glass of which a spherical mirror forms a part each called center of a curvature. Pole, the midpoint of a spherical mirror is called pole. Center of curvature, the center of a spherical transparent glass. The transparent glass of which a special mirror. Principal axis, the line joining pole and center of curvature. The line joining parallel pole and center of curvature. Radius of curvature. The distance between the pole and the center of a creature. The distance between the pole and the center of a curvature. The distance between pole and center of a curvature is called radius of curvature. The and the center of curvature is called the radius of curvature. Focus. A point on a principal axis. Throw which a ray of a light incident parallel to principal axis. Principal axis passes or a pair to passes after reflection. Poker length, the distance between the pole and focus, the distance between the pole and poker, the distance between the pole and the distance between pole and focus, the distance between pole and focus, each called poker length. Trigonometric ratio, trigonometry inverse, trigonometry function, trigonometry function ratio. Sin theta is equal to p by h, sin theta p by h, cos theta b by h, tan theta p by b, cosec theta h by p, sec theta h by b, cot theta b by p, cosec theta 1 by sin theta, cosec theta 1 by sin theta, sec theta is equal to 1 by cos theta, cot theta is equal to 1 by tan theta is equal to sin theta upon cos theta, cotec theta upon cos theta, sin theta upon sin theta, sin theta 0, mm, sin cos tan, cosec sec cot 0, 13, 45, 60, 90. 0, 1 by 2, 1 by root 2, root 3 by 2, 1 cosec theta, 1 by root 3 upon 2, 1 by root 2 upon 1 by 2, 0, 10, sin theta 0, 1 by 2, 1 by root 2 by 3, 0, 1 by 2, 1 by root 2, root 3 by 2 1 cos theta 1 root 2 by 2 1 by root 2 1 by 2 0 0 1 by root 3 0 1 by 3 0 1 by root 3 1 root 3 not defined cosec theta not defined 2 root 2 2 by root 3 1 cosec theta 1 root 2 upon root 3 root 2 2 not defined root 3 1 1 by root 3 0 pi equal to 180 pi equal to 180 pi by 2 equal to 90 degree 90 degree 90 degree pi by 3 360 degree 60 45 45 pi by 4 pi by 6 30 degree trigonometry identities sin square theta plus cos square theta is equal to 1 1 plus sin 10 square theta sin square theta plus cos square theta is equal to 1 1 plus 10 square theta is equal to sec square theta 1 by cot square theta is equal to cosec square theta sin square theta upon cos square theta sin square theta plus cos square theta is equal to 1 1 plus 10 square theta is equal to cosec square theta 1 by 10 square theta is equal to cosec square theta sec sin square theta plus cos square theta is equal to 1 1 plus 10 square theta is equal to sec 1 plus cot square theta is equal to cosec square theta relation between degree and radian relationship between degree and relation 2 by 2 pi is equal to 360 2 pi is equal to 360 pi is equal to 180 1 radian is equal to 180 by pi 180 by pi 57 degree 60 per meter per minute graph just sign x then equal to minus delta range minus 1 period 2 pi cos cos y cos x domain r minus range minus 1 period 2 pi y tan x is equal to sin x upon cos x cos x not equal to 0 domain r minus 2 and plus 1 pi by 2 range r y is equal to cot x cos x plus upon sin x not equal 0 sin x not equal 0 domain r no, r minus n pi y sec x is equal to 1 by cos x is equal not equal to 0 domain r minus 2n plus 1 pi by 2 range minus I minus 1 pi sine of trigonometry function in different coordinates 1 all on 2 sine theta cos theta 2 sine theta cos theta 3 10 cot cosec sec sine cos 10 sine cos 10 1 all sine cosec 10 cot sec cos sec trigonometry ratio of a compound angle cos a minus b is equal to cos a cos b plus sin b cos a minus b is equal to cos a cos b plus sin b cos a plus b is equal to cos a cos b minus sin a sin b Sin A plus B is equal to sin A cos B plus cos A sin B. Sin A minus B sin A minus B is equal to sin A cos B minus cos A sin B. Tangent tan A plus B is equal to tan A plus tan B. 1 minus tan A tan B tan B. Tan A minus B is equal to tan A minus tan B. 1 plus tan A tan B. Cot A plus B is equal to cot A cot B minus 1 upon cot B plus cot A minus B is equal to cot A cot B plus 1 cot B minus cot A. Important result: cos A plus B cos A minus B is equal to cos square A minus sin square B cos square B minus sin square A. Sin A plus B sin A minus B is equal to sin A square B is equal to cos square B minus cos square A. Tan A plus B plus C tan A plus tan B plus tan C minus tan A tan B tan C. 1 minus tan A tan B minus tan C minus tan C tan A. Adding and subtracting sin A plus B sin A cos A minus B cos adding subtracting sin A plus B plus sin A minus B is equal to 2 sin A cos B. Sin A plus B minus sin A minus B is equal to 2 cos A sin B. Cos A plus B plus cos A minus B is equal to cos B. Cos A minus B minus cos A plus B is equal to 2 sin A sin B. Formula to transform the sum of a different into product. Sin C plus sin D is equal to sin C plus D upon 2 cos C minus D upon 2 sin C minus sin D is equal to 2 cos C plus D upon 2 sin C minus D upon 2 cos C plus cos D is equal to 2 cos C plus D upon 2 cos C minus D upon 2 cos D minus cos C is equal to 2 sin C plus D upon 2 sin C minus D upon 2 multiple answer multiple angle cos 2A cos 2A is equal to cos 2A minus cos 2A is equal to cos square A minus sin square A equal to 2 cos 2 A minus 1 is equal to 1 minus 2 sin square A sin 2A is equal to 2 sin A cos A 2 tan 2A is equal to 2 tan A minus tan square A sin 3A is equal to 3 sin A minus 4 sin 3A cos 3A is equal to 4 cos 3A minus 3 cos A sin 2A is equal to 2 sin 2 tan A 2 tan A by 1 plus tan square A cos square A is equal to 1 minus tan square A upon 1 upon tan square A tan cube A is equal to 3 tan A minus tan 3A minus 1 3 tan square A value of sin 15 cos 15 tan 15 sin 75 cos 75 tan 75 sin 15 root 3 minus 1 upon 2 root 2 cos 75 is equal to root 3 minus 1 upon root 3 minus 1 root 2 root 2 cos 15 root 3 plus 1 upon 2 root 2. Tan 15 is equal to root 3 minus 1, 1 plus root 3. Sin 75 is equal to root 3 plus 1 upon 2 root 2. Tan 75 is equal to 1 plus root 3 minus 1. Sin 18, 18 is equal to root 5 minus 1 upon 4. Cos 18 is equal to 10 under root 10 power 2 root 5 upon 4. Cos 36 is equal to root 5 plus 1 upon 4 sin alpha plus beta plus sin alpha plus 2 beta dot plus sin alpha plus minus 1 beta sin alpha plus sin alpha plus minus 1 beta upon 2 sin beta upon 2 sin n beta upon 2. If b is equal to alpha sin alpha plus sin 2 plus sin n alpha sin n plus 1 upon 2 into sin n alpha by 2 sin alpha 2. Mm, Elementary function, elementary function, elementary function, elementary function, elementary function. Equal to the current is alternating current. Electromagnetic waves, electromagnetic waves, electromagnetic waves. A charging electric field produce charging magnetic field and vice versa, The given two rise are transverse wave is called electromagnetic wave. Electromagnetic wave in this magnetic change electric field is mutual perpendicular to charging magnetic field and also perpendicular to direction of propagation of EMW electromagnetic wave. So it is called transverse wave. The moving electric charge, the moving charge flow of electric current is the base source of production of electromagnetic waves. Properties of electromagnetic waves. Important for 3 marks. Electromagnetic properties of electromagnetic wave. Properties of electromagnetic waves. Electromagnetic waves are do not require materials medium for propagation. It means they can also travel in vacuum. It means they can also moving. It means they can also travel in vacuum. Electromagnetic wave, 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 electromagnetic waves. Magnetic wave. So, total waves, total number of waves comes into 4 days. Electromagnetic waves are changing electric wave produce changing magnetic field and vice versa. These leads to rise or transverse wave is called electromagnetic waves. Electromagnetic properties of electromagnetic waves. Important for 3 marks. 3 marks. Properties of electromagnetic waves. Electromagnetic wave do not require material. Electromagnetic do not having electromagnetic do not require material medium for their propagation. It means they can also travel in vacuum. Electromagnetic wave do not require material medium for their propagation. It means they can also travel in vacuum. The speed of electromagnetic waves in is vacuum is given by the speed of electromagnetic waves in a vacuum. The speed of electromagnetic waves in a vacuum. C equal to 1 by 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 under root uh, omega naught e naught omega naught e naught equal to 3 into 3 into 10 the power 18 10 the power 8 meter per second. C equal to 1 by under root omega naught e naught in the speed of electromagnetic waves in a vacuum. C is equal to 1 by omega under root omega C is equal to 1 by omega under root omega e naught, where omega absolute permeability of a vacuum 4 pi into 10 pi 10 minus 7 tm per per a E naught absolute permanent of vacuum 8.84 into 10 power minus 12 and minus m minus c2. The speed of electromagnetic wave in any medium is given by v equal to 1 by 1 by v equal to 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 1 by under root v equal to 1 by 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 under root omega e. The speed of electromagnetic any medium cube c equal to 1 by omega naught under root omega naught e naught v equal to 1 by under root v a omega omega e Parability B omega parability of the medium E parability of the medium. Electromagnetic are transverse in nature. Electromagnetic transverse in nature. Electromagnetic transverse in nature. The moving electric charge in basic source of production electromagnetic waves. The moving electric charge is basic source of electromagnetic waves. Electromagnetic transverse in nature. The electromagnetic is transverse in nature. The electromagnetic transport energy. The electromagnetic transport energy of a principle for a one place to another place in the medium without transforming particle of the medium. The electromagnetic transport energy of a particle. The electromagnetic transport energy of a particular particles from one place to another place in the medium without transferring particles of the medium. The electromagnetic can be ref- mm, related and reflected. Electromagnetic can be reflected in so phenomenal of interference and poly polyrhythm. They are electromagnetic magnetic wave electromagnetic have are there are seven types of electromagnetic waves. There are seven types of electromagnetic waves. Radio waves, microwaves, infrared, invisible visible light, ultraviolet ray, X-ray ray, gamma ray. For any types of wavelength lambda, frequency v is equal to c by wavelength lambda v is equal to c by c v is equal to c by lambda, where c is equal to c into 10 the power 8 c is equal to 3 into 10 the power 8 meter per second. Electromagnetic spectrum, electromagnetic spectrum. The arrangement of all type of electromagnetic in a whole range of their wavelength and or frequency. The arrangement electromagnetic spectrum. The arrangement of all types of electromagnetic waves in a whole range. The arrangement of all types electromagnetic waves in a vacuum in a whole range of their wavelength and frequency, each called electromagnetic spectrum. Wavelength in meter increasing, frequency hertz increasing. Radio, microwave, infrared, visible UV rays, UVJ, ultrawave, ultraviolet, X-ray, gamma ray, gamma ray. 10 8, 8, 1, 3, 6, 9, 12, 14, 10 the power 9 to 10 the power 8, 10, 10, 10 the power 11 to 10 the power 12, 10 the power 14, 10 the power 15, 10 the power 17, 10 the power 20, 23. Which of the following has the largest frequency? Which of the following has the largest frequency? X-ray, 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 X-ray. Come. Largest frequency. Which of the following has smallest wavelength? Smallest wavelength. Smallest wavelength. Smallest wavelength. Smallest wavelength. Smallest wavelength. Smallest wavelength. Huge use of type of electromagnetic waves, electro length, wavelength range, 10 the power 8 to 10 the power minus 1 meter, frequency range 10 the power 2 to 10 the power 9 to 10 the power 10 hertz. In FM transmission, in telecast the TV program telecast in TV program in secular phones or wireless mobile, in satellite system, microwave, wavelength range, 10 the power minus 1 to 10 the power minus 3 meter, frequency range 10 the power 9 to 10 the power 10 to 10 the power 11 to 10 the power 12 hertz. They are also used in communication system. They are also frequency, wave. Mm, frequency. They are also used in communication. They also used in communication. They are also in communication. They are also used in communication. They are also in communication. They are also used in communication. They are used in microwaves, microwaves in making cooking warm the food. They are in winter radiator. They are used in atomic and molecular research. Research. These are in um, radio wave, micro, infrared, hot bodies, rated IRAs, hot body, infrared. Sun is the greatest natural source of infrared. Sun is the greatest natural source of infrared. Microwave range. 10 the power minus 3 to 10 the power 6 meter frequency 10 the power 10 to 10 the power 11 no, 10 the power 14 hertz. It is used infrared. Infrared are used in heat wave. So they are used treatment of a muscular strain. They are used in a greenhouse to absorb water vapor and CO2. They are used to relate related invisible writing on antique walls. Infrared coming from sun keep the earth warm. Warm. The infrared coming from sun keep the earth warm. Visible light visible light help up to see beautiful warm frequency rate 10 the power 14 hertz to 10 the power 15 hertz visible light stimulates sense of a light to our eyes stimulate it is it is used in photography it is used for it is used visible light. It is used to in photography. It is used as to in purpose. It is a greatest source of energy. Full human life. Full human life. The greatest source of energy. Full human life. Human life. UV rays. UV rays UC ultraviolet. Sun is the greatest source of UV rays. Wavelength 10 the power minus 6 to 10 the power minus 9 meter. Frequency range is equal to 10 the power 15 to 10 the power 7 hertz. They are used to surgery instrument. They are used to making drinking water free for bacteria. The they are used to making drinking water free for bacteria. Free drinking water free for bacteria. They are used to detect fingerprint on the body. They are used to detect. They are used to detect fingerprint on the body. X-ray. X-ray was discovered by Professor Ranton in 1895. 1895, Professor Ranton. Frequency range 10 the power 17 minus 10 the power 20 hertz. Wavelength range 10 the power minus 9 equal to 10 the minus 12 meter. They are used to locate frequent in bones. X-ray are used in radiotherapy to cure skin cancer. They are used to detective agency to detect valuable bacteria like gold, gold diamond in the bag of suitcase. German gamma ray have the largest frequency, so they have largest power. Wave range is equal to 10 the power minus 12 or 10 the minus 14 meter. Frequency range 10 the power 20 is equal to 10 the power 23 hertz. They are also used in treatment for cancer. It is used in transmitter, Treatment of a cancer. It is used to treatment of a cancer. They are used in food baking. They are used in food baking. There are get value information about structure atom and nucleus. Next. Takes the branch of physics to deal about the story light and phenomenal react to light. Optics, branch of optics, ray optics, ray optics, the branch of optics in which light is represented form of ray. It is a branch of optics in which light is represented in form of rays. These rays light the form of energy which stimulates sense of stimulate to our eyes. The light always transversal in a straight path in the homogeneous medium. The speed of light in a different medium are different. The light travel with the largest speed in vacuum equal to 3 into 10 to the power 8 meter per second. It is denoted by C is equal to 3 into 10 to the power C C equal to 3 into 10 to the power 8 meter per second. Reflective index, the ratio, the ratio of speed of light in a vacuum to the speed of a light in the medium V is called reflective index of a medium. It is denoted by omega is equal to C by P. Reflective index, reflective index. The medium is unitless and dimensionless. Reflective index of any medium is greatest or equal to 1 omega less than 1 omega less than 1. The reflective index of a different medium or different calculate speed of the calculate speed the calculate the reflective index of a different medium or different calculate speed of light in a medium having a reflective index 3 by 2 c is equal to 3 to 10 millimeter per second. Omega is equal to 3 by 2, omega is equal to 3 by 2, c is equal to 3 into 10 to the power 8 meter per second, omega is equal to c by v. 3 by 2 is equal to 3 into 10 to the power 8 meter. 8 meter. Reflective, relative, reflective index, the reflective index of one medium with respect to reflective index of another medium is called relative reflective index. Relative index of a first medium. Uh, medium respect to with respect to relative relative function reflective index reflective index of a second medium reflective index of a first medium reflective index of a second medium. The medium having larger diffractive index compared the another medium which called denser medium. The medium the medium having the medium having a smaller reflective index comparison with another medium is called rarer medium. Reflection of the light, the phenomenon of a bouncing back of a ray of light in a same medium after striking on a surface is called reflection reflection of light. Angle I is equal to angle I of incidence angle R is equal to incidence angle of reflection. Angle is the angle made by incident. Incident. Angles made by incident light and reflective with reflecting surface are called German angles. They are denoted by alpha and beta. Alpha is equal beta. Law of reflection of light. Incidence light, reflective light normally are lies in same plane. The angle or incident must be equal to the angle of reflection. Angle I is equal to angle R mirror the part of a transparent glass whose one side is a polished is called a mirror. Types of mirror. Plane mirror, spherical mirror, plane mirror. The part of a plane transparent glass whose one side is polished is called plane mirror. A spherical mirror, the part of a the part of a spherical transparent glass whose one side is polished. The part of a spherical transparent glass whose one side is polished. It has two parts: concave mirror, convex mirror. Some basic terms related to some basic types. Some basic types related to a spherical mirror. Pole. The midpoint of a spherical mirror is called pole. The midpoint of a spherical mirror is called pole. Center of curvature. The center of the spherical transparent glass of which a spherical mirror from one part from a part is called center of curvature. Principal principal axis, the line joining pair pole are center of curvature, each called the principal axis. Radius of a curvature. The distance between the pole and the center of a curvature is each called the radius of a curvature. Curvature focus. A point on the principal axis through which a ray of light incident parallel to the principal axis passing or a pair to pass after reflection is called The fine for poker length, 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 poker length. The distance between the pole and focus is called poker length. Poker length. गाइस, चलते हैं, बाय गाइस, नेक्स्ट लाइव